In this video, we're going to talk about the area of a triangle with trig formula. But first, we're going to start off with finding the area of triangles using the regular formula, 1/2 base times height. So in the first example here, we do have a right triangle. So the base and the height are super easy to find because the base is 6 and the height is just whatever this leg is. And when I have two sides of a right triangle, I can use Pythagorean theorem to find the missing side. A squared plus b squared equals to c squared. A and b represent legs, and c does represent the hypotenuse. So 10 is the hypotenuse. So I do have to make sure that I plug 10 in for c. Other than that, the order doesn't matter. 6 squared plus b squared equals 10 squared. So we have 36 plus b squared equals to 100. If I subtract 36 on both sides, let's do 100 minus 36. And then if you take the square root, you have 8. And now we can plug into the area of a triangle formula, 1/2 base times height, because now we know that the base is 8 and the height is 6. So if I type that in, I get 24. And we do measure area in square units, so I'm just going to write down units squared. The next one is a little bit trickier to find the area, and we're going to find the area of the whole big triangle. So I'm going to outline it in purple. We're going to find the area of this whole triangle. We do know the base. We do know that the base is 11, but the problem is that we're not given a height. If this dotted line is an altitude, we can definitely find the height. We can definitely find the altitude, but it's not provided to us. And the way that we can find the altitude is by using trig, because we do have a right triangle. We do have a focus angle, the 64-degree angle. From the 64-degree angle, this is opposite, which is what we're looking for, the height. And we are provided with the hypotenuse, which is 5. So if I write down SOHCAHTOA, I'll see that sine is the choice that I need with opposite and hypotenuse. So sine of the 64-degree angle is equal to opposite, which I'll just refer to as x, over hypotenuse, which is 5. If we cross multiply, because we're solving for a side, we have 5 sine of 64 is equal to x. And that's our height. So now if I plug it in to the area of a triangle formula, my base is still 11. And now I found my height to be 5 sine of 64. I'm going to type that in. Five sine of 64. And around to one decimal place, that's approximately, I'll keep a couple, 24.717. That was a lot of work. We had to use trig to find the height. We had to hope that the dotted line was an altitude, which it might not have been. And if it wasn't an altitude, then it would have been impossible for us to locate the height if it wasn't an altitude. Let's try to express the area of this triangle a little bit more generally. Pause the video and see if you can figure out how to express the area of this triangle using just the letters that are given in the diagram. Unpause the video when you're ready to see the solution. Since the area of a triangle formula is 1/2 base times height, using the letters here, I can represent the base of the big triangle as A, and I can represent the height as H. So 1/2 A times H. Now, let's write a ratio for sine of angle C. So angle C is over here. So opposite, hypotenuse, that's what we need for sine. Because if we write out SOHCAHTOA, Sine is O over H. So sine of angle C is opposite, which is H, over hypotenuse, which is B. If we take a moment and we look at our area formula and our ratio for sine of angle C, what's in common? You might be thinking the H is in common, and that's true. So I'm going to take a moment and I'm going to just solve this for H by cross multiplication. And now that I know what H is, I can substitute that back into our area of a triangle formula. Because B sine C is H. And this is our new formula for area of a triangle with trig. The A and the B don't necessarily have to be labeled as A and B. They just mean any two sides next to each other in a triangle. And angle C just means the angle in between the two sides. When you have a triangle, any triangle, doesn't have to be a right triangle. When you have a triangle, generally we use capital letters to represent the angles, and we use lowercase letters to represent the sides. Side A with a lowercase a is the side across from angle A. Side B with the lowercase b is across, opposite from angle B. And side C is opposite from angle C. So A and B just represent two sides that are next to each other. And angle C just represents the angle that's in between the two sides. Kind of like side, angle, angle, side. So now I want to go back to the original question that we were working on that was a little bit tricky to find the area using the regular area of a triangle formula, 1/2 base times height. And I want to show you how using the new formula makes this a lot easier. Keep in mind also that this triangle that we're finding the area of, that we found the area of already, we're just going to do it again using our new formula to see how much easier it is. See how it's not a right triangle? Because this formula is so nice because it does not have to be used for a right triangle. So our new formula is 1/2 AB sine C. We do have two sides next to each other. We have the 5 and we have the 11. So that's going to be our A and B. And then sine of the angle in between. We did have the angle in between those two sides, 64 degrees. And let's type this into our calculator. And look at that, the same exact area that we got before. But this was so much easier because we had the information to use the new formula. We had two sides next to each other and the angle in between. So whenever you have that information, it might even be easier to use this new area of a triangle formula to find the area rather than the older one. Because if you were using this formula, you would need to know the base and the height, not just any two sides next to each other. Okay, let's do some practice. Let's find the area of triangle ABC. Side A is 6, side B is 7, and the sine of angle C is 1/3. Careful, angle C is not 1/3. The sine of angle C is 1/3. But we are talking about angle C. So this looks like a perfect setup for our new area formula because we have two sides next to each other and we're talking about the angle in between. So our area is 1/2 AB sine of C. Our two sides next to each other are 6 and 7. And the sine of angle C is provided to us as 1/3. So all we need to do is type that into our calculator. I'm going to leave it as this. You can type it into the calculator yourself, but I'm going to leave it as this to save time in the video. And I do recommend that as we do the next problems, you pause the video, try it yourself, and then unpause to see if you got the correct answer when you are ready to see the answer. Finding the area once again. Perfect setup because we have two sides next to each other, the 9 and the 12. And then sine of the angle in between, which is 150. You can type this into the calculator yourself. Moving along. We have an isosceles triangle and a vertex angle of 30 degrees. Perfect setup for our new area of a triangle formula because we have two sides next to each other and the sine of the angle in between. Once again, you can type this into the calculator, 10 times 10 times sine of 30. I'm moving along. And notice how I'm drawing all of these triangles as not right triangles because they don't have to be right triangles to use this formula. For regular trig ratios, they have to be, but not for the area formula. Because we got the area formula from using a non-right triangle. That's how we made the formula. Okay, perfect setup once again. In the next one, we're given that the area of a parallelogram is 20. Remember, a parallelogram can be divided into two equal triangles. If the area of the parallelogram is 20, that means that the area of each of the triangles is 10. It tells us that two adjacent sides are 8 and 5. So what we just need to do is we just need to look for the angle in between. So perfect setup. For our new formula, the area of one triangle is 10. The sides are 8, 5, and we're finding angle C. So 8 times 5 times 1/2. Let's do that on our calculator. And that's 20. Divide both sides by 20. And then to find angle C, you can take inverse sine of 1/2, and that gives you angle C. And once again, you can type that into your calculator yourself. Okay, these are the last couple of questions we're going to do. We have an equilateral triangle. So this requires the use of a 30, 60, 90 triangle because it says exact value. So if you drop an altitude, this is 30. So we have 30, 60, 90. The ratios of the sides of a 30, 60, 90 triangle are 1 to radical 3 to 2. We have the two part, the hypotenuse. So to get from 4 to the smallest side, we just divide by 2. It's a 1 to 2 ratio. So the smallest side would be 2. And now we have everything that we need. And if you wanted to fill this one, then this one's 2 radical 3. But we just needed the 4 and the 2, two sides next to each other, and the angle in between. So four to sine of 60. Now for this one, that's the area of one of these 30, 60, 90 triangles. But the equilateral triangle is made up of 2 of these. So when you get your answer, you are going to have to multiply by 2. So whatever you get as your answer, just multiply it by 2 afterwards. And that would be the full area of the equilateral triangle. Or you could just edit your formula not to have the 1/2. And that works as well. Okay. This is another one with equilateral triangles. And this time it's giving us the area. And we need to find one of its sides. Okay, we know that the angles are 60 degrees in an equilateral triangle. We know that the area is 72 radical 3. And we know that both of the sides are the same. So I'm just going to call it like x and x. So x times x would be x squared. And then sine of 60 degrees. So I'm just going to solve. So first I'm going to get rid of the 1/2 by multiplying by 2 on both sides. So that's 144 radical 3 equals to x squared sine of 60. Then I'm going to divide sine 60 on both sides. So 144 radical 3. Oh, I should use the fraction by then. Divided by sine of 60. And that's 288. It works out nicely. Now I do need to take the square root to get x by itself. That does not work out nicely. So, does it say the round? It does not. So if we want to leave it as the exact value, we could leave it as radical 288. We can try to see if it simplifies in our calculator. Oh, it does simplify. We're looking for whole numbers. The last time we see whole numbers, which is here, 12 radical 2. Okay, so 12 radical 2 is the measure of one side. And that's the exact value because it doesn't say the round. Okay, the area of triangle MOP is 30 square inches. MO is 10. OP is 8. Find angle O. So area is 1/2 AB sine of angle C. 10 times 8. Oh, I forgot to put the area in. The area is 30. And we are finding angle C, the angle in between. So this is 30 equals to 10 times 8 is 80. Half of that is 40. So if I do divide by 40 on both sides, I get 3/4 equals sine of C. So then we can do inverse sine of 3/4 equals angle C. And we can round to like the nearest tenth, approximately 48.6. And just one more example, just to show you on the most recent Regents exam, the question that they asked about this. It just said find the area of this triangle to the nearest tenth. You're given two sides next to each other and the angle in between. So all you would need to do is plug into the formula. Type this into your calculator and round to the nearest tenth.